This is a custom LCD module designed for a benchtop high voltage power supply. Hello, are you looking for a display for your next project? If so, a custom LCD could be the perfect fit. In this video, I'll show you how simple it is to design and manufacture one. I'll even show you how to build a low-cost prototype of a switch membrane with metal dome buttons, just like the one on this front panel mockup. Now sure, a custom LCD is more limited than a modern touchscreen. But if your product is connected over Bluetooth, Wi-Fi or Ethernet, you can use a phone or a tablet to display any extra data you want, while the LCD handles only the essentials. Here's a quick overview of the workflow using open source softwares. You can design your LCD and switch membrane in Inkscape and export the SVG or DXF files to the manufacturer. Then, KiCad can be used for the electronics and FreeCAD for the mechanics. Once it's assembled, the last step is programming and testing the embedded software. I'll cover that in another video, where I'll also show an optional Python workflow you can use to validate your custom LCD design before sending it to manufacturing. So let's dive in. There are three main types of LCD technology to choose from: reflective, transmissive, and transflective. Reflective LCDs use ambient light and have dark segments on a light background. Since no backlight is needed, they are great for low power consumption and sunlight readability. Transmissive LCDs rely on a backlight, which allows for light segments on a dark background. For example, the background can be black or deep blue, and the segments can be any light color you want, as the color is printed on a transparent film acting as a filter. Transflective LCDs combine both effects, making them usable in a wide range of lighting conditions. Liquid crystals respond to electric fields by changing their orientation. With the help of polarizing filters, this effect can be used to either block or allow light to pass through the display. TN is fast and cheap, perfect for simple digits or icons. VA offers better contrasts and wider viewing angles, and IPS is what you'll find in high-end displays and monitors. The custom LCD I am showcasing in this video is a black TN negative LCD, a transmissive type with a white LED backlight. Once you've chosen the technology that best fits your needs, the next step is designing the module, defining its graphical elements, dimensions, and specifications. Inkscape is a great tool for this. You can start by adding a rectangle to define the active area of the module, lock it in place, then add the graphical elements and the colors you need. If you're interested, I can cover those details in a future video. Just let me know in the comments. Electrically, each segment behaves as a tiny capacitor. Apply an AC voltage and it turns on. No signals, it stays off. But never use a DC voltage, as it damages them over time. The AC voltage and timings are handled by the LCD driver. This can be built into your microcontroller or managed by an external driver over a serial interface. Either way, you just write 1 or 0 to the driver's registers to control each segment. To reduce pin count, multiple segments can share a common pin. The maximum segment count is simply the number of commands multiplied by the number of segment outputs. When sending files to the manufacturer, you'll usually provide both the design drawing and a document with specification, dimensions, colors, viewing angle. For example, 12 o'clock means optimized for viewing from top, around 25 degrees, while 6 o'clock is for viewing from bottom. In this design, there are 175 segments, driven by a standalone IC that supports up to 200 segments, 4 commands times 50 segments. You can also label your segments in the technical drawing. This makes it easier to match with the connection table the factory sends back after routing. For example, COM1 pin 1 maps to segment 13B, the B segment of digit 13. When sending files for manufacturing, you can provide the SVG directly and let them process it, or export a DXF file yourself. If you export the DXF file, make sure to flatten your shapes, otherwise strokes may overlap the field areas and cause issues. Then, before production, the factory provides detailed documents for review to ensure everything is correct. These typically include on one side the LCD module details, such as dimensions, pin routing, visual appearance, and on the other side the LED module with the number of embedded LEDs and the required driving current. In terms of cost, there's an initial tooling fee, around $150 for a module like this. After that, the unit price depends on the order quantity, but even in low volumes, the cost is usually just a few dollars per unit, including the backlight. Let's now jump into KiCad. To use your custom LCD in your schematic, you'll need to create both a new symbol and a new footprint. In the symbol and footprint I am showing, I also included the 4 pins corresponding to the backlight. At this point, you may also create the 3D model of your LCD module using FreeCAD and attach it to your footprint. To do this, in the footprint editor, you go to the footprint properties and under the 3D model tab, you set the link to the step model you exported from FreeCAD. The symbol and footprint for the driver circuits can usually be found online, but if not, it is easy and fast to create them yourself. As you can see on the schematic, the connections are straightforward: power supply, common pins, segments, and the serial interface. With well-organized connections, routing isn't difficult. And before exporting the board, you can double-check everything in KiCad's 3D viewer. When the PCB is ready, you can export the full board as a step file back into FreeCAD for integration in your product. And finally, for the bill of materials, you can also use an open source software like LibreOffice Calc. Now, the process for designing the switch membrane is quite similar. The main task is to correctly define the graphics and the layout. Then, having them manufactured is fast and easy using online quotation system like GRPanel. The graphical elements and layout consist of the background colors, the buttons, and eventually openings for a display, status LEDs, rotary encoders or connectors. There are also a few specifications to choose from. For example, the surface finish, the material type, the material thickness, and so on. All those options are well explained in the quotation systems of online manufacturers and their documentation. However, if you're prototyping or working on a home project, you can build a switch membrane yourself using a low-cost 2-layer PCB and printing your graphics on adhesive vinyl with a standard home printer. To assemble it, first apply a transparent spacer layer to the PCB, then place the metal domes. They come in different sizes and with different stiffness levels. Those are 10 mm and feel fairly firm to press, at about 220 grams of force. Then you cover everything with the printed vinyl layer. You could also add an extra thin protective film on top to protect the vinyl from scratches. For assembly with the electronics, you can use screw terminals mounted on the PCB and plastic standoffs to set the correct height of your PCB and LCD module. This approach is nice for hobby or home project, as it lets you test different design and layouts without committing to a production run. In terms of cost, a switch membrane design like this in production would cost about $400. And that's it for the process of making your own custom LCD with a switch membrane. If you found this useful, give it a like and let me know your thoughts in the comments. Thanks for watching and see you in the next one.